So we saw how superposition of waves can happen, right? Now what we are considering is we are considering a monochromatic source. So in front of this monochromatic source, we have two slits. So we'll consider two slits and we have to have a screen. So considering, let's say this is one slit, is another slit, and right in front of it we have a screen. Okay, so this is the first slit, so let's call this as S1. Second slit, let's call it as S2, and this is the screen. See, now what we have to consider is S1 and S2 will act like sources for the screen, correct? Basically, these are the secondary wavefronts. Okay. Now remember, S1 and S2 should be coherent sources, right? Now what we'll consider is, we'll consider one point, let's say some point P here, and from S1 to this point, and from S2 to this point. Okay, so let me tell you what we are doing here. From S1 to P, from S2 to P, a ray of light, or you can say wave fronts, are going. Now remember, here S1P and S2P are wave fronts. So what we are doing is, either we get a bright light or a dark light, because that's what is happening in interference. So maxima or minima. Now for that mathematical expression we have to derive. Okay. Now from S1P, or from S1, basically let's say Y1 is equal to A1 sine of omega t. This is the displacement of the particle. From S2 we have Y2 is equal to A2 sine of omega t plus phi. Phi being the phase difference. Okay, phi being the phase difference. Now at P we have Y1 plus Y2. So we have at P Y is equal to Y1 plus Y2. Okay, so if we add them, we get Y is equal to A1 sine of omega t plus A2 sine of omega t plus phi. Okay, so sine of omega t plus phi, we have to expand it. So we'll get this as A1 sine of omega t plus A2 sine omega t cos phi plus A2 sine phi cos omega t. So this is what we get, sine of A plus B. Now what we'll do is, sine omega t will take common. So you'll end up with A1 plus A2 cos phi into sine of omega t plus A2 sine phi cos omega t. So this is what we get. Now what we are doing is, we are assuming certain things. Okay, so what we are assuming here is, we'll call A1 plus A2 cos phi as A cos theta, and A2 sin phi as A sin theta. Now when you do this, so A1 plus A2 cos phi becomes A cos theta. So we have A cos theta sin omega t plus A sin theta cos omega t, correct? So this is what we are going to do now. So you'll end up with Y is equal to A cos theta sin omega t plus A sin theta cos omega t. Okay, now Y is equal to, see, if you take A common, don't you think this is of the form of sine of A plus B? So we'll get Y is equal to A sine of omega t plus theta. So what we concluded from this is the displacement at P is also simple harmonic motion. Okay, simple harmonic motion where A is the amplitude and theta is the phase difference. Okay, I repeat this again. At point P, this particular function gives us that the displacement is a simple harmonic wave and amplitude is A and the phase difference is theta. Okay, now we got this. To find the amplitude, see, amplitude is nothing but the square of the amplitude, correct? That's basically the intensity square of the amplitude. So we had A1 plus A2 cos phi. This is basically A cos theta, correct? And A2 sin phi, we named it as A sin theta. Now square and add them because we need the value of A. So if you square and add them, you'll get this as A1 square plus A2 square cos square phi plus 2A1 A2 cos phi plus A2 square sin square phi is equal to A square into cos square theta plus sin square theta. Anyway, this value becomes 1. Next, here if you take A2 square common, that will also be 1. So we end up with A square is equal to A1 square plus A2 square plus 2A1 A2 cos phi. Right, so this is basically the intensity. Okay, so intensity is square of the amplitude. So this is what we get. So we can write like ultimately the intensity I is equal to A1 square plus A2 square plus 2A1 A2 cos phi. So this is what we get for the intensity. Now for maximum and minimum, in other words, we can also say it as the constructive interference and destructive interference. Now see, for constructive interference, so let me show you how the wave pattern should look like. Okay, so we'll take the sinusoidal wave because we are considering everything to be sinusoidal in nature. So let's say this is the y-axis and we have to consider the x-axis now. So consider this to be the x-axis. Okay, now what we'll do is I'll just try to write a sine curve. So imagine this is the sine curve. Okay, now we have a peak amplitude here and this is the negative peak amplitude. Now for a constructive interference, if we have a crust in the first wave, the second wave should also have a crust, correct? Or if it's a trough, the second wave should also have a trough. So basically, if we are looking at a constructive interference, then it should be something like this, correct? Then it's a constructive interference, right? Here both the crusts will add, both the troughs will add, so we'll get a constructive interference, meaning we'll get a bright fringe. Okay, now let me ask you one more thing. Should it always start from the same point, or what if it has started from somewhere else, maybe like this, and again it would have started like this, meaning my one wave is already done. This is one wave is done. So basically how much is this? It's wavelength, correct? So this is lambda. One lambda is already done. So this is the second lambda what we are talking about, correct? So what we can conclude from this? It need not be the same starting point. It could be before that or it could be after that. The only thing is it should be 1 lambda, or it could be 2 lambda or 3 lambda, or in general, can we say it has to be just n into lambda, correct? So what we say here is, for a constructive interference, the path difference has to be n lambda. In other words, what we can say is, if x is the path difference between the two waves, so x is the path difference, then we have x is equal to n times lambda. Now, n value is any integer, so like 1, 2, 3, 4, on and on and on. Okay, now whenever we have n lambda, what we get is a constructive interference. In other words, a bright fringe. Okay, same thing for a destructive interference. Destructive interference is basically a dark fringe. Now for that, what we need to have, if you have a crust, then we should have a trough, or when you have a trough, we should have a crust, correct? So what we get is, it should be something like this, right? This is where both of them will cancel. Now for such cases, what we need to have, it should be an odd multiple of lambda, correct? Because if this is 1, if you move half the way, then you will get 1 and half. 1 and half is where crust and trough will meet, right? So if x is equal to 2n plus 1 by 2 into lambda, then you will have a destructive interference. Okay, here also n value starts from 0, 1, 2, 3, on and on and on. So let me repeat it again. So if you have x to be the path difference, if the path difference is a integral multiple of lambda, then we have a constructive interference. So this is constructive. If you have an odd multiple of lambda, then this is a destructive. This is a destructive interference. So this is the whole theory behind constructive or destructive interference. Okay, so and what is the intensity of the, basically the particle, or the intensity at that particular point.